Hey, so I posted. There is an assignment posted. It is this one, the one you're looking at here, one right down here, right down below. So chemistry compounds unit, ions worksheet 1. Now remember, an ion is a charged atom. We talked about this before. So an atom that has a charge, and they get a charge by doing what? I hope you're thinking about it. What do atoms do to get charged? It has to do with which particle? The electron. Remember, the protons are stuck in the nucleus. They can't get out, and protons can't come in. Whatever's in the nucleus is in the nucleus. All right? But the electrons out in the cloud around the outside, especially the valence ones, the ones that are furthest out, those can come and go fairly easily. So if something becomes positive or negative, it's because of those valence electrons either coming or going. All right. Now, a little demonstration that, again, you missed if you weren't here, but I took a balloon, you see, like this. So a balloon, and I would show you and demonstrate for you, but I don't have much hair going on here. See, I just cut it this morning. I mean, it's close. It is a very close haircut I just gave myself this morning. So I don't have enough to do anything with here, but I asked a volunteer in class, and I rubbed the balloon all over their hair, this person. Now, I don't know if my jacket could do something. And an amazing thing happened. An amazing thing happened. When I would bring the balloon up from their hair, you would see hairs, individual hairs start standing up, wanting to get near the balloon. And so we talked about, okay, what does this mean? Like, what has happened? Well, it turns out that hair has this ability to give away or lose electrons very easily. Number one, because they're just little spindly, thin, hairs. They can give off electrons easily. Or I actually, hold on, before oh my gosh, someone mentioned that was called static electricity that was happening, which is true. That's what we call it, static electricity. Static actually means stationary, not moving. And some people just call it it's static. Well, static what? Because static just means not moving. And so the question is, what's not moving? And that's why it's important to say static electricity, because it's the electrical charges that now aren't moving. Static electricity means motionless or stationary charges. So electricity, everything that we have that deals with electricity, whether it's plugging something into the wall, or whether it's a battery, or whether it's dragging your feet along the carpet and touching a doorknob and getting shocked, everything, lightning, everything that we have that is dealing with electricity is dealing with what two particles? What two particles that we've been talking about? Electrons and protons. Yeah. Those are the only two that have charge. Neutrons don't even have a charge. So when we're talking about electricity, anything dealing with electricity, it's involving protons and electrons. All right. Now, when rubbing this on someone's hair and then the hair starts standing up, it means it's what to the balloon? If the hairs start standing up trying to get to the balloon, it's because they are what to the balloon? Again, the word I'm looking for is attracted. They are attracted to the balloon. Okay, that if the hairs are attracted to the balloon, then what does that tell us about the charge on the hairs versus the balloon? What charge do the hairs have versus the charge that the balloon has? Now, go back to what I had already said. The hairs tend to give away or lose electrons easily. The balloon actually takes electrons off of the hair easily. Now, I don't even have enough here. I can't even probably do that, make that happen. If I stuff my beard, maybe it would work, but not this. There's not enough there. So, are you hearing what I'm saying? If the hair gives off electrons easily and the balloon takes electrons easily from the hair, then what charge is the balloon becoming? It's taking electrons off the hair. Then the balloon must be becoming negative. The hairs then, because they're losing electrons, the hairs are becoming positive. And because the hair and the balloon are oppositely charged, what do we know about opposites? Opposites attract. And so the hairs, once they've had some electrons stolen from them by the balloon, those hairs become positive and they are trying to get to a place that's very negative, which is now the surface of the balloon. Now, I'm assuming you have experienced static electricity before. Like, for instance, like I had mentioned a second ago, dragging your feet along the carpet. So now your feet, which probably have shoes on them, and those shoes with either plastic or rubber soles on them are actually stealing electrons, most likely, from the fibers of the carpet that you're walking on, and your body's getting loaded with electrons because you're stealing them from the carpet. And as soon as you touch something that's a good conductor, like a doorknob or something that's metal, those electrons that you've been loading yourself up with are going to jump off of you, because what do we know about like charges? Charges that are alike repel. They don't want to be around each other. You're loaded with electrons, and a bunch of electrons all in the same place. They don't want to be there that close, that many of them. And so they're going to jump off. And when they do, it kind of hurts a little. So this idea of static electricity, it comes back to that some atoms can have electrons taken from them easily. Other atoms take electrons easily. So you have two different things going on. All right, some atoms are gaining electrons because they're taking them away. Other atoms are losing electrons because I guess they can lose them easily. And we have this thing called static electricity. Now, why is it called static? Again, because those electrons, once they get stuck to the balloon, they're on there and they're just in one place. They're wherever I was rubbing the hair, that's where the electrons are. They're stuck. They're stationary. They can't go anywhere. They're just there. And then the hair becomes positive. And the only way to make it not positive is to rub your hand all over it. And then the hair is going to then take electrons from your hand as you've rubbed your hand on your hair, and then kind of go back to neutral, go back to normal. So with this in mind, I want you to take a look at this worksheet, and I want you to answer the questions, draw the diagrams based on the questions. And then I will actually post another video on this post that has this video. I'll post a second video of me explaining what the answers are and like everything with this worksheet. So do this worksheet, and then I will post a video that explains and goes over it sooner than later. So think about the whole charge situation. And remember the octet, we were talking about the octet thing before. So all of that, all the stuff that we've already learned that we just tested on, you need to know all of that to do this next part. So do this worksheet and then look for another video that I'll post that shows you kind of what all this stuff means. So, hey, take care of yourselves. We'll see you later.